Hello, I'm Patrick Bartell, process heating expert with Powerblanket. I've been in the process heating industry for over 25 years, and Powerblanket provides industrial and commercial heating solutions for any application. Newsflash, it froze in Texas again. As a Texas resident, I know that it freezes up at least 8 times a year, every single year. It froze this year, it's going to freeze again.
Today, ERCOT explained that 40% of all Texas power plants have gone offline during the weather emergency. That's about 70 to 80 power plants not working when Texans needed them the most. ERCOT continues to urge everyone to conserve as much electricity as they can. Here in San Antonio, more than 170,000 CPS customers are still without power.
ERCOT's been in the news a lot, and there's been a lot of blame for a lot of different people, a lot of different organizations for failures in the power plants in the Texas freeze in February of 2021. ERCOT's the organization designed to provide reliability to taxpayers of the state of Texas, but in fact, nationwide, there's an organization called NERC, which is the National Electrical Reliability Council, and they cover every region and every state in the United States and Canada to provide, again, reliability and uptime on power plants. So ERCOT exists for the purpose of keeping power plants running. So when you turn your light switch on, it comes on. And there's also, like I said, the national organizations that do the same thing. But every single year it freezes and freezes hard. It doesn't matter, it just happened a little bit more this year, and it's going to happen again next year. So these companies work very closely with those power plants in order to help them have a maintenance and reliability program that will ensure that they keep things running. So it's really not a matter of ERCOT or NERC or some government funded entity doing their job. It's a matter of the actual plants and the applications in the plants and what froze up there that caused the problem. Within the power plants, they have technology that's been around for 70 years. And that technology is electric heat trace and steam trace, things we've used for years and years and years. So they continue to use the same exact solution for the old problem that they have, freeze ups in the winter. Electric heat trace and steam trace aren't as reliable as some of the newer technologies that are available today. Electric heat trace a lot of times is either installed improperly or it's old, it doesn't get replaced. On top of that, bypass valves or instruments will tend to have a box placed around them, a heated box, and those boxes heat air inside a box, not the most efficient way to transfer heat into a transmitter or a pump body or a valve. The places we see heat trace most often fail is on valves, instruments, and improperly installed or improperly maintained heat trace. Let's talk about valves for a second. Here's some examples of some solutions that people had to come up with in order just to keep the plant running. Duct tape and garbage bags taped around a valve. It probably worked just fine for a couple of days, then it got wet and didn't work. Over here, you've got some homemade insulation on a pipe to keep that pipe from freezing. Best thing that they could possibly do over time, but it just doesn't work. Heat trace needs good insulation in order to work properly, and a lot of times the insulation doesn't allow the heat trace to work. We're all familiar with this site. This is a valve with heat trace on it. Every industrial plant in the United States that has heat trace probably has something that looks a little bit like this. It looks really pretty underneath the insulation. When you pull the insulation off, you've got this wad of heating cable. The instruction sheets show this nice, even insinuated picture of heat trace on a valve. And here you've got what it really looks like in real life. It's very rigid and hard to work with, but it's all they've had to work with for years. Then when it comes time to maintain that valve, they remove the insulation jacket, they remove the heat trace, and they put the valve back in, and they leave the heat trace hanging, and who knows if they even get the insulation jacket back on where it needs to go. This is a steam bypass valve. You know what this is. If you have a freeze up on the steam bypass valve, you can't run your plant. This valve is also very difficult to get heat on because of the way that it's shaped. When it's out in the wind like this, it'll freeze up. The actuator will freeze up, the valve body itself will freeze up. And it's critical to have these protected from the elements in the winter. Here's another example, a common valve flange to flange application with an actuator on it. A lot of times you'll see heat trace and insulation on the valves and pipes, and you're gonna take good care of those thermally, but the actuator is left exposed to the elements, even with the space for the wind to blow right through it. When these actuators are kept warm, they run longer, they run more reliably, and they keep your process running. One of the best solutions for this problem right now is an insulated heating blanket with heat built inside of it. Many of you know what this is. We have these all over our plants, but nobody has a blanket with heater built inside of it. So here's the same actuator with a blanket over the top of it that's rated for the hazardous area classification that has an integrated heater inside that runs off of 120, 208, or 240-volt power. And it solves the problem of that actuator being exposed to the elements without a subpar 70-year-old solution. So we can heat the entire valve assembly for you, just the actuator, just the valve, or we can wrap the whole thing in one big box for you. You can even install our blanket over the top of heat trace running through the blanket. Whatever you need, let us know. We'll fix it for you with a Powerblanket. Another thing that Powerblanket can do is we can cover your instruments with heated boxes. We can actually cover the transmitter head or the actual instrument itself. If you'll notice in these pictures right here, you've got level controllers on the side of the tank that contain liquid in them. We could build a box that's a rectangular box that goes right around the level indicators with a peak window on it. And as you can see on this skid, a current example, there's actually heat trace on the outside of the insulation, completely ineffective and hard to replace. Customers do this all the time in desperation and trying to keep things running, and they'll wrap something around it just to keep it warm. In this case, the heat trace is touching insulation, not even touching the pipe. So it's almost completely inefficient. We can also heat your valves completely with the entire thing wrapping around the valve and the actuator itself, or we can do separately just the actuator and just the valve. So in power plants and other industrial plants alike, there are a lot of times instrumentation that are exposed to the elements, such as this drum level indicator. When these freeze up, they can't read the level on the vessel. In this case, in a power plant, they don't know how much water is available to make steam for a turbine. So they have to shut the whole plant down. All you have to do is either put a blanket around this and heat it, or have a way of keeping the entire system out of the elements. The best solution for this application is a power blanket wrapped around the level indicator with a window that you can see the level on. This is a transmitter head used for a lot of different applications and a lot of different plants. In an industrial plant, they're used to measure a variety of different processes, but if they're not covered and kept warm, they don't work properly. And if they're heated, they do work properly. Transmitter warmers by Powerblanket are the best solution for keeping these transmitters at the right temperature. They can be run on 120, 208, or 240 volts AC, and can easily run on any breaker circuit that you have available. Previously, we had talked about what they are and that if they get cold, they don't function properly. So what we have here is a solution that's pretty common. Put a box around it, put a heater in the box. Except those heaters don't last very long. They're heating air and they're just working as hard as they can. So they're notorious for going out and having a cold box with a cold instrument inside of it. Another solution customers come up with is they just put a tent around their instruments. It could be a tarp, a shower curtain. They build scaffolding. Here you can see a pretty elaborate ring shower type system around these. They'll put them around pumps and valves and pipe bodies. They'll do all kinds of things. And then they'll shove a bunch of light bulbs in there or bullet heaters. And it doesn't really work very well because those tarps wear out over time. The challenge with this application is you're actually just heating air. You're not actually trying to heat the instrument head. With a Powerblanket solution, you're actually contacting the surface of the transmitter or the valve or the pump body. In this case, there's going to be a failure. It's going to get too cold, and light bulbs and bullet heaters don't work very well for this application. Heat trace has always been a great solution. It's been around for over 70 years in the same form that it's used today. And insulation blankets have been around for a long time as well. These insulation blankets are in every plant you've ever seen where people want to keep things touch safe for OSHA purposes, or if they want to keep minimize their losses, but it doesn't have any heat in it. So you have to put heat trace inside of it. It's very difficult to get the heat trace around the flange pair, around the instrument or whatever. So if you can imagine this plus electric heat trace got together, they would create something like this, a Powerblanket blanket heater that has integrated heat on the inside of the blanket, can run on 120 to 240 volts AC, can have built-in temperature protection if your instrument is sensitive to a high temperature. It's a great solution. It's an all-in-one solution out of the box that'll keep your transmitters, pumps, and valves warm. When you see these in a plant, they always have to be removed in order to do maintenance on valves or instruments. And where do they usually end up? On the ground. If you have one of these attached to your valve or your instrument, when they take it off, it's going to be dangling by a cord. There's probably a better chance it's going to get put back on. Power blankets can be made in any shape or size you can imagine. If you can get us a drawing, a photo, or let us come out on site and measure your application, we can make it fit for you. These power blankets can be made to fit right onto your instrument or your valve or your pump and conduct the heat directly into the product versus just trying to heat a big open space of air. Electric heat trace has been used as a freeze protection means for a long, long time. Again, the technology hasn't changed in over 70 years. Here is an application where we have self-regulating heat trace attached to a pipe. Here's an example of heat trace shorting out for various reasons, whether it's in the junction boxes or on the pipe itself. Poorly insulated valves and actuators, heat trace not properly attached to a valve itself, insulation removed for repair purposes and not put back on properly, and people using this for a step stool when they got to stand up on top of something. When that insulation is damaged, it's never going to work properly. Heat trace just can't work without a proper insulation system. And the second that insulation system is compromised, the heat trace no longer works properly. Here's some of the horror stories I've seen over my 25 years in the industry. Insulation, again, it's damaged and compromised on the end. There's no possible way that moisture can't stay off of that insulation. Insulation removed or just plain worn out over time. And then on the top here, some homemade solutions. They had to come up with something. They had to keep the plant running, but it didn't last very long, I can promise you. Another really common solution for heat tracing or for heat conservation on the fly or as you have is to take some of this fiberglass Cerakote tape and just tape it on top of the heat trace, or to just run it over the top of it so you can try and conserve some heat on that heat trace. The problem is it's not watertight. Up top here, it's very common for you to see insulation taken off of heating applications altogether and just left off. Heat trace puts out very little wattage per foot and cannot work without insulation. Let's talk about Powerblanket Complete Thermal Solutions. We can do the entire heat trace system for you. We can design it so that it will function properly, give you instructions for your yearly maintenance to make sure it's running properly. We can also cover your valves and instruments with a tight fit electric heated blanket rated for Class 1 Division 2 areas. If you have a short repair that you need to do, you don't need to run and get a garbage bag and a bunch of duct tape. You can put one of our Powerblanket heaters on there. They come in standard sizes for standard pipe. We can also do the control system for any heat trace Powerblanket system that you can come up with. Finally, we can also heat your tanks and your processes that need flanged immersion heaters. The Powerblanket has a full line of process heating and controller offerings. Give us a call today. Turn us loose on your plant. Let us measure up your valves and instruments. Let us look at your heat trace system and give you an idea of what you can do to improve your operations and improve the long-term production of your facility when thermal applications are required.